Hi, folks. We're going to take a look at number 17 from page 188. So they give us a diagram for a bridge. Okay, and the cables are made up of parabolas, and they're asking us to find equations for these three parabolas. Now, as we've seen before, when we talk about a parabola, of course, we're talking about a shape that sort of keeps going. All right, but sometimes we're only interested in part of that parabola, like when we're modeling, say, a ball that's being thrown. It makes a parabola. We're not necessarily interested in the whole parabola. All right, so they tell us to put the lowest point of that middle parabola at the origin. Okay, so the first thing I'm going to do is, as we often do when we're trying to model some real life situation, is we place a Cartesian plane over it. Okay, so we're going to place our x and y axes here, as they suggest that we do. So this is my x, this is my y. So that means that the vertex of this middle parabola is at 0, 0. Okay? Now, of course, to find the equation of a parabola, it's great to have the vertex, but we know we need another point. So let's see what other points we can determine here. Well, if this whole thing is 100 meters, that means to this end, it'll be 50. And to that end, it'll be another 50 meters. But of course, on our Cartesian plane, this is going to be negative 50. All right. And since this is the base of the bridge and the cables are 30 meters high, means this point here is going to be 50, 30. Okay. And so this point here is going to be negative 50, 30. Okay. So now what we'll need, now actually, now that I think of it, we also have this parabola here, which notice stops. It's like half of one of these parabolas. So this point here would be the vertex of this right-hand parabola. All right. But if this length here is 50 meters, means this length here is going to be 50 meters. So from 50 plus 50, that's going to be 100. And similarly here, this is going to be 50 meters. So from negative 50 to negative 100. Okay, so I'm not sure that we actually need all these points, but we might as well put down what we have. So with all this information, we'll hopefully be able to come up with the equations for these three parabolas. All right, so let's start with the middle one. All right, now since I'm given information about the, so we'll call this one 1, call this one 2, and we'll call this one 3. So since we're given information about the vertex of the parabola, I'm going to work with the vertex form. Okay, so anytime you want to work with vertex form, y equals ax minus h squared plus k. Okay, now you could have probably figured out this without writing the general form, but what are h and k? They're both equal to 0. So normally I wouldn't write this line out, but just to make sure that you see, how we get to where we get, this is like x minus 0 squared plus 0. So in the end, the form of this equation is just ax squared, which is not surprising because if we compare it to x squared, it has the same vertex. It'll just have been stretched. All right, so our goal is to determine this value of a, which tells us how much it's been stretched. Okay, and we expect a to be positive since it's opening upward. And so what do? Well, we just need another piece of information. And I actually have two pieces of information because I have these 2 points, which are also on this parabola. So pick either one of them, stick it into your equation, and you can solve for a. So I'll pick this one here. So when y is equal to 30, x is equal to 50. All right, and here 30 equals, well, 50 times 50 is 2,500, so 2,500 a. So a is equal to 30 over 2,500. Divide both by 10, so 3 over 250. All right, so what's my final answer here? The equation is just equal to y equals 3 over 250 x squared. All right. So now let's move on to the second one. Now, for the second one, I could actually follow the exact same path, which I will, but I think we're going to see in a little bit that it's unnecessary. I'm not going to do that for number 3, but just to show you that I could have if I didn't think of my alternate method, which I'm going to show you. Okay, so I could start with the same thing, y equals ax minus h squared plus k. Okay, so I look for the vertex, and the vertex occurs at, well, x equals 100 and y equals 0. So y equals a times x minus 100 squared plus 0. Okay, and now I need to input another piece of information. Well, hey, this 5030 is also on that parabola. All right, so I put in 30. A is 50 minus, 100 squared. Okay, plus 0, so 30 is equal to 50 minus 100 is negative 50, and negative 50 squared is just positive 2500. And we see, okay, I'm not going to write out the whole thing, but if we divide, we can divide both by 10, and I'm still going to end up with 3 over 250. So my equation is going to be y equals, again, 3 over 250 times x minus 100 squared. All right, but I would say that this is not surprising at all, because these cables, at least the way they've drawn it, okay, make the same parabolas, or at least parts of parabolas. So if I think of this parabola as just being the middle one shifted over by, well, how many units? Well, 0, 0 goes to 100, 0. So it's just shifted to the right by 100 units. And of course, we know that when we're dealing with horizontal translations, right, we always see the opposite operation. So if it's shifted to the right, if I'm adding 20 to the x value, I should be seeing x minus 100 inside the bracket of the equation. So I could have actually figured this out without going through this process, but I just wanted to show you that this is always something you can do, that once you have the basic form of the equation, you pick another point to solve for the a value. So now for number 3, well, I'm not going to do all that work because I realize that this parabola here, okay, is just this middle parabola shifted to the left by 100 units, okay? So if I want to shift it to the left by 100 units, so the a value is not going to change, still 3 over 250. The only thing I'm doing is I'm going to take this parabola now and shift it 100 units to the left. So it's going to be x plus 100 squared. Okay. Now there's part of the question I haven't answered yet. It asks for what values are these parabolas valued, for what x values. And we see here that I'm not interested in this whole parabola. This parabola keeps going on either side. I'm only interested in the parabola from negative 50 to positive 50. Okay, those are the only x values I'm interested in. So let's see how we could write that down. So we could write it out explicitly and say, only for x from negative 50 to positive 50. Okay, I could be very explicit. Or we can use some good notation. And I think you've seen these inequalities before, as we could say that x, okay, and if I want to represent what we call an interval, so from one number to another, well, it has to be less than or equal to 50, but greater than or equal to negative 50. What this means is that x lies between these two numbers. And because it can have the value of negative 50 and positive 50, that's why I use not just less than, greater than, I use less than or equal to, greater than or equal to. So in this case here, what am I interested in? I'm only interested for number 2 from x equals 50 to x equals 100. I'm not interested in the rest of that parabola. So how would I write that? Again, we always look left to right. So we could write 50 is less than or equal to x is less than or equal to 100. And this represents all the x values only between these two numbers. And similarly here, we're going from negative 100 to negative 50. So again, always from left to right. So negative 100 is less than or equal to x is less than or equal to negative 50. All right, so just to recap, when you're given a physical situation, you want to model with a function, try to put over your scenario a Cartesian plane, determine important points on your functions. In this case here, for each of the 3, we had information about the vertex, so that's why I worked with the vertex form of the parabola, okay, and then use another point to determine the missing a value, okay. In this case here, you could have determined the other 2 parabolas just by shifting them left and right, all right, and you can specify the regions for which you're interested in by using these inequalities like less than or equal to, greater than or equal to. Okay, that's it for this one.